Hello Math 125 students. I decided I'm going to make another video where I go through an old exam. You will see on Canvas already, I have a video I made last year where I went through an old exam. Ultimately you need to be reviewing the homework, looking through lots of old exams, working through some old exams in detail. You got to gear up. The exams are tough in this course, so you have to be, hopefully you've actively been engaging with the homework and building towards this. Just a couple things, and you also see some of this in the other video. So first off, on my materials page, let's just pull this up real fast. On Canvas, I'll have these things that have the rules, and I'll go through this in class, but if you're worried about this, you are allowed a calculator, but this calculator model only for the test. So just remember that, get that calculator model, you'll want this one. You can't use a graphing calculator. You get one sheet of handwritten notes front and back, and then you're going to write your answers on the test. The test itself will be front and back. It'll have 5 pages of questions and then a couple blank pages. We digitize the exam after you take it, meaning we scan it and grade it so that you get a digital copy later. But it does mean we want everything on the test. So typically there's enough space, but if you run out of space on a question, you can write C scratch sheet and write on the back page for more work. You have 80 minutes. So you got to manage that, about 10 to 12 minutes a page. If you do that, then you're going to be well within the time. If you actually have more time than that, 15 minutes a page. So that's your gauge. You can't spend 20 minutes, 30 minutes on a page. But anyways, you do need to show some work. I don't need to see every excruciating detail, but enough work to prove you did it. We do give partial credit. So if you tend to show not very much work and then you have the final answer wrong, you're going to lose more points. And so you really should show enough work so we can give you partial credit. But don't go out of your way. I mean, you can be succinct. Show the work you want graded. If you're sick or something, there aren't makeups, but I want you to contact me and we'll prorate, meaning we drop this exam and make the other ones worth more. But I want you still to contact me immediately as soon as you can. And the only thing I'm a little picky about, definitely follow the instructions on the question. If the question says change the bounds, then you got to change the bounds, that sort of stuff. But the only thing I'm a little picky on is I've noticed over the years that sometimes students leave their final answer in the form like square root of 4 or tangent of 0 or cosine of 0. So you might quiz yourself if you know these. So we sort of reserve the right. We might take off a point if you leave a final answer in this form, if you don't simplify well-known values of well-known functions. So that's it. So that's the only thing. You got to present your answer a little bit to us. You don't go out of your way. You don't have to do tons of simplifying, but some of these things I'm warning you. There's a certain amount of presentation. And then when it comes to what we're doing, we did Riemann sums. We did antiderivatives and finding a constant. We'll probably have something like that on the test. Those are like those tomato problems or anything where you're finding the constant. Fundamental theorem, calculus, both parts will definitely appear. You'll probably have a net change, total change question. You'll definitely have substitution a few times, area between curves. You will not have cylindrical shells. That's the one topic. That's from 6.3. But we will have a volume question. It's just the volume question. You'll be able to do the cross-sectional method, which I'll talk about in class. All right, enough of that. Watch my other video for even more advice on studying. If I were you, I would glance through the homework. Take like 5-10 minutes and look through the homework. Make sure there's nothing in there that surprises you. If I give the exact same question as a homework, you don't want to be confused by the wording. You'd be amazed how often this happens. A student raises their hands and they say, the wording on this question is confusing. And then I say, that's the exact same wording from the homework. So you don't want that to happen to you. You don't want to be confused by wording you've already read. So glance through the homework. Make sure you would know how to start a similar question. And then start looking at old exams. And as you're doing that, you should be making your note sheet. Okay, so let's think about this. And you can put anything you want in your note sheet. If you're having trouble like with the facts, you can go to my materials page and say, hey, maybe I want to put the unit circle just so I'm faster at some of these trig values. Maybe I don't know my antiderivative, so maybe I'll put that on my note sheet. Maybe there's some other facts I don't remember from this sheet that maybe I want to put on there. There won't be anything you need that you haven't already used in the homework. So any tool or idea you're dealing with is either something in the homework or a fundamental idea to the calculus skills you've been building in this course and the previous one. Okay. So the exam will look something like this. You'll have a cover page. It'll have this thing. This is more for us to kind of, there'll be 5 pages of questions. This is probably what it'll be. This is a reminder of the rules. Simplify well-known values, and then we go. Okay, so here's the first question. So question 1, you might pause the video and try it yourself if you haven't yet. Let's pick something here. So what is this question? This question is, can you simplify? Do you know that you have to simplify? And then can you simplify and integrate? And I should say, I'm doing this on the fly here. So if I make a mistake or a typo, you're welcome to tell me. But full solutions are here. This is the winter 2015 exam. You can go to my archive. Cleaned up solutions are there. But what I'd like to do in this video is talk through it. Now, if I make a small mistake in here, please give me some grace. You can let me know. But the point of this video is to show you how to think through the problems. If you really want to go through the solutions in detail, you can come back and look at the solution. So, okay, let's go. Sometimes in these videos, I'm quickly going and describing, and I miscopy a number, and then everyone gets mad at me. So let's try to not do that. All right, so here we go. So the key thing here is you can distribute. You can distribute. You have a common denominator. And so the very first thing I would do if it was me doing this problem is I probably would do a few things at once. I would write this as x to the 1/2 all over 2x to the 4th. I'm separating the fraction. I can do that because it's a common denominator. It is always good to think of it. It's basically distribution. I can say this a couple different ways, but you've definitely seen this a few times in your homework. That's step 1. We are separating it into 3 separate problems we can do. Now we need to simplify those a little bit if we're going to do it. Now if you ever forget this, what you're allowed to do, I like to come over and run an experiment. Here's a random experiment. This means x times x times x times x. This is just a random one I'm trying here. Oh, they cancel. Oh yeah, the rule is to subtract. So the rule here is to subtract. I'm going to have to do 1/2 minus 4. Yeah, that's kind of tricky, but I think we can figure it out. It's 1/2 minus 8/2. It's 7/2. So negative 7/2. So what I see is x to the negative 7/2. What you might say here is what happened to the 2, but the 2's cancel. What I see here is 3x to the negative 2, and what I see here is 3. So hopefully I did all that right. Again, if I have a typo, the point of this video is the idea of how you do it. But now you're here, and then you can integrate. So you need to add 1. You do a lot of stuff with these fractions. If you're adding 1, it's 2 over 2, so it's going to be negative 5/2. It's going to be negative 2/5. This is going to become x to the negative 1. This is going to become positive 3 because you're going to divide by negative 1. This is going to become 3x. It's going to be plus c. And don't forget your plus c. You can make a little note for yourself that if this sign is here, this needs to be here, so you can scan through and see if you've forgotten. You don't have to simplify. You don't have to do anything else. You can just stop there. Maybe we'll take a quick glance to make sure I didn't do anything silly. Yeah, we got the same solution there. That's it. How long did that take us? I think if you practice, that problem is definitely, like a 3 or 4 minute question, no longer. Okay, so that should take you about 1/3 of a page. That shouldn't be too bad. You shouldn't be scared by that. Okay, what's this one? Okay, there's a lot more going on. This is a mess. And so the answer is it's a substitution. So every problem you're either simplifying or doing substitution when it comes to integration. So very first thing is you're going to pick u. We have some advice on this I gave in class, which is to pick the denominator. If there is not an obvious other choice, pick the whole denominator. It's typically going to make things easier. Are there other substitutions we could do? Yes, but this is going to be the nicest. Then don't forget to take the derivative. So this is the point I was making in class just the other day. We need to practice and practice and practice this. If you like, you can do the thing I said in class about rewriting this. du is dx. And then we're going to change everything except the swiggle. So here's where that unit circle in your note sheet could really save you time. What I mean by that is if you could do this quickly, sine of pi over 6, you could quickly get this bound. What I just did is I plugged this in here. This actually is a time saver. You say, well, don't know what sine of pi over 6 is, so let's pull that up real quick. So if you put this on your note sheet here, here's what you would have. Pi over 6 is right here. Zoom in a little bit. On the unit circle, if you don't know how this works, so the x-coordinate is cosine. The y-coordinate is sine. Right now I want sine of pi over 6, which is a half. It's sitting right there. Sine of pi over 6 is a half. So you can see how having this is faster than having to even pull it up on your calculator. I mean, ultimately, we just need to know these. You could also be using the fact sheet here. Hopefully you've been doing this where you say, okay, sine of pi over 6 is a half. It's nice if you can quickly do that. It's just a time saver. 2 times a half. So it's 3 minus 1. So it's 2. So this is going to be 2. And then the problem is going to be nice the rest of the time. I dealt with the messy plugging in right away. You could, of course, wait and plug in later, but if the instructions say you must change the bounds, then you'd have to do this, and I often do say that. Now I'm going to plug in at pi over 2, so it's going to be 3 minus 2 sine of pi over 2. You really should know sine of pi over 2 is 1. So this is 3 minus 2 times 1, it's 1. And then you say, well, that's confusing. The top number is bigger than the bottom, but that's okay. That happened to you in the homework a few times if you did this. This becomes a u. This is 1 over negative cosine of x du. And then the whole thing is these cancel. And then you have negative 1/2. I'm pulling out the negative 1/2, the integral from 2 to 1. If you so desire, you can flip. You don't have to, but often this happens when the numbers are opposite. You may want to flip because it just makes it nicer. And then we're ready to go. This is the log. You can put absolute values or not, as we discussed in class here. You don't have to because the numbers are all positive. This is log of 2 minus 1/2 log of 1. And log of 1 is 0, so it's 1/2 log of 2. So as scary as that question might have looked, we often on the first page of the test have a question that looks sort of scary. But ultimately, you should go, oh, it's substitution. And you just start to work. If you know what you're doing, that does not take more than 3 or 4 minutes. If you don't know what you're doing, it takes longer, but that's part of what we're testing, is your efficiency to do the problem. So if we pull up this exam, let's look at this real quick. Hopefully this is helpful. I'm trying to find different ways to help people. That's what we got. So you want to get to a point where something like that is fast. Sometimes I have 3 questions on the first page, sometimes I have 2, but we'll probably on the first page of the test, it will be integration like this. Okay, so then you get to this one. Scary looking, don't know what to do, it's substitution. If you've prepared and looked at old exams, something like this won't surprise you. You initially think, well, this doesn't work because dx is just du, and we talked about this. This is the situation where there's still an x floating around. And when that happens, you go back up here. This will happen. Somewhere on the first or second page of the test, you will have to do a problem like this. So you don't want to be surprised by it. Okay, so then ready to go. So this is the integral. This is u plus 2. That was the clever little trick. This is u to the 1/2. Now some students got stuck here. I remember when I gave this test because they didn't know how to expand. They didn't know that u to the 1 times u to the 1/2 is u to the 3/2. I think that was the confusion for some students. And then this times this would be 2u to the 1/2. And that's why we can do this. Once we do substitution, it's possible to distribute. This becomes 5/2. This becomes 2/5. This becomes 2. This becomes 3/2. This becomes 2/3. This becomes plus c. And if I clean it all up, it's 2/5 x minus 2 to the 5/2 plus 4/3 x minus 2 to the 3/2. So very likely a question like that will appear on the test. You don't want to be surprised by it. That's testing whether you know how to do substitution, even when it doesn't work perfectly. Okay, same sort of thing like this. This was, this is probably one of the hardest questions that ever appeared on one of my old tests when it comes to integration on the first test. What function has a derivative that looks like x cubed? Is this bit of advice? So this question students really struggled with, and I probably would not ask this again because I didn't realize that they would have such confusion. What students tried to do is so you can try this as a challenge, pause the video. What students tried to do is this, which is a very reasonable idea, but the problem is you get this, and this is not a 7, and it doesn't cancel, and then you keep trying to work. So I had wrote this little hint, hoping students would have an idea of what to do, but I said nobody did very well on this question, so this was a very challenging question. my advice was trying to say, well, what if you could get x cubed as your derivative? Can you think of a way to make that happen? Well, that would only happen if u was x to the fourth. That's what I was trying to get people to do with the hint. Again, most people did not get the hint. So if you didn't get the hint when you just tried this, this was a very challenging question that quarter. Very few people got it. So if you didn't get it, don't worry. But I would try x to the fourth. But then you say there is no x to the fourth in the problem. And the issue is when I originally wrote this question, I wrote it this way. But then I thought this was too easy. So I originally wrote the question this way. And then I thought, well, that's too easy. I want to have a hard question on the test. So then I rewrote it this way. And that made it really hard for students. Now, why does it look easier when you write it this way? Because when you write it this way, it's more obvious. Oh, yeah, there's an x to the fourth there. So that's sort of tricky. But you get dx is 1/4 x to the third du. And then you get the integral. The negative one becomes 1 because we're plugging it in here. The 0 becomes 0. This becomes x to the third. This becomes u squared plus 1. This is 1 over, again, tricky problem. I did just randomly pick one of my old exams, so I didn't intentionally try to get this in here, but the integral from 1 to 0 of 1 over u squared plus 1 du. And then you go, well, why in the world can we do that? Well, that's arctangent. So it's 1/4 arctangent of u from 1 to 0. And notice I'm leaving the smaller number on the top. That's okay. Arctangent of 0 minus arctangent of 1. Oops, I bumped something. Just a moment. There's a little button on my pen that I accidentally bumped. Okay. And then you say, well, I don't know what arctangent is. Again, that could be on your note sheet. That's in the unit circle. If you don't realize it, it's sitting right there. Because tangent is sine over cosine. Oops, I did not click the right one. Unit circle. So if you're asking when is tangent equal to 1, that would be when sine and cosine are the same. Okay, so tangent is sine over cosine. It's this value 1/2 over this. So tangent of pi over 6 is 1/2 over square root of 3 over 2, which ends up being 1 over root 3. Tangent of pi over 4 is square root of 2 over 2 over square root, so it's 1. Tangent of pi over 3 is this over this, so it's square root of 3. So the unit circle also contains the tangent values. It also contains inverse tangent values. It's all there. So there's some examples of this here if you didn't realize that. That's why we emphasize that so much in pre-calculus courses. So anyways, you would want to know that this is, something's going on with my pen. Just a moment. Okay, figured out my technical difficulty there. We're back in business. So anyways, maybe I didn't figure out my technical difficulty. Oh, I have still an eraser. Okay, so that's equal to 1/4 0 minus, and this is pi over 4. So it ends up being negative pi over 16. And this one does come out to be negative if we pull up. Sometimes that bothers people, but remember your intervals can be negative. In this case, the function, we're plugging in negative numbers to a function that's negative. So yeah, there, it just come out to be that. Okay, so I think we matched up. So I'm trying to, I've made these videos before and I made like a typo and people got really mad about it. So I'm trying to pull up the solutions each time. But hopefully you're getting the idea. So then we have this weird question that says your physics instructor gives you a function. It's defined this way. Now the moment you see this, the integral from negative 3x to x squared, you should think fundamental theorem of calculus part 1. So this is that idea that you can take the derivative of this without actually integrating. So, quick detour here. Well, let's not do a detour. Let's keep going. So this is this function. The question is asking you for the slope of the tangent line. So something like that is something that sometimes people go, well, that specifically, though that word wasn't on the test, but that's more of a foundational calculus idea. You should know that that means the derivative at 1. So the question is asking you for the derivative at 1. So the question is really just asking you what's the derivative. This is a super fast question. Fundamental Theorem of Calculus Part 1 says, take whatever is your integrand, and this is my integrand, and I'm going to write it twice. I'll show you why in a second. And the Fundamental Theorem of Calculus Part 1 says that you can just plug this in here. Basically, the derivative and the integral cancel each other off in this way. So this is going to go here. And similarly, if there's a bottom one, this is going to go here. There's going to be a minus between them. But there was a catch we talked about, which was that you have to then multiply by the derivative of whatever that was. And that's the old chain rule together. That's it. So this answer was 2x e to the x, I guess that would be x to the fourth, plus 3 because of the minus and the minus. This is a multiplication symbol. E to the 9x squared, if you want to simplify. And then the question said, what's f prime of 1? So it asked you to plug in a 1. So it's 2e to the 1 plus 3e to the 9. It is 9, yes. And that's it. Nothing more to it. And just stop. This is a really, really fast question. Done. Okay, so this is one of those things where if you eat up a whole bunch of your time on a question like that, it's like you just weren't prepared. So that's one of those things. You should know that's coming somewhere on the exam. Okay, a particle is traveling up and down in a straight line with, and this is part of where just looking through lots of exams can give you some comfort, so you don't just eat up so much time reading a question over and over again. Here's the velocity. Find the total distance. So again, this is another one of these. We should immediately know what to do. Total distance is asking for us to make the velocity positive everywhere. And then we should know that step 1 is to set this equal. So as you're studying, it isn't just enough that you did 1 or 2 homework questions. You have to say, now do I know how to start? So you immediately solve when this equals 0. Then in this case, we factor. It's t squared minus 1 equals 0. And there's a few possible things that can happen here. You could have t equals 0, or you could have t equals negative 1, or you could have t equals 1. So 3 possibilities, but in between 0 and 2, the only thing that's interesting is 1. 0 technically is in between, but it's on the end. Okay, so now I know whatever's going on in the picture, and you don't even have to have an accurate picture. I know that the function changes possibly from positive to negative here. If you wanted to take some time and graph it, you could, but that would be kind of a waste of your time. But just visually, I wouldn't do that on a test. But visually, you don't have to know that much. What you know now is that it's 0 here and it's 0 here. If you wanted, you could even just plug in a number, like plug in a 2, and say, well, if I plug in a 2, it's going to be 4 times 8 minus 8, which is positive. So it somehow goes up. I'm not worried about being precise at all. And then if I plug in numbers in between, like a 0.5, 4 times a half cubed minus 4. So this is just if you want to, I think that's negative, so it comes down like this. But the only reason I drew that was so that you could see, oh, we're going to get a negative area here and a positive area here. And when we talk about total distance, we don't want that. So what do? We take the function and we put absolute values around it. Effectively, what does that do? That redraws the graph, and so that it looks like this. And then we talked about in class, you don't even have to know what the picture looks like or anything. You just need to know what that area is and what that area is, and you need to do them separately. The reason you want to do them separately is you don't want there to be any cancellation. Okay, so the thing I said was, step 1, find when it's equal to 0. Step 2, split it up. And when we split it up, I'm going to drop the absolute values and just compute the area, whether it's positive or negative. I don't care at the moment. The most important thing is that I've split it up. So then I'm going to compute this, and I'm going to compute this completely separately. Right? So this is going to become t to the fourth minus 2t squared. I did a little bit of simplifying. So that ends up being, I think it ends up being negative 1. And then I do this one, it's going to be t to the fourth. Sorry, I'm doing some calculation here because I just want to get us a little further along. 16 minus 8. So it's 8 minus negative 1. I think it's 9. I did that really fast. I don't know if I'm right. We're going to check in a second. But I got that this was 9 and this was negative 1. So based off of that, what is the area of this? Well, this is 1 and this is 9. So the total distance traveled by the particle is going to be 1 plus 9, which is 10. Let's double check my calculations real quick against my solutions and my solutions manual. Okay, it is 10. Good. Okay, let's keep going. So that's an important idea. So far it's good as you go to kind of stop. It takes, we had to do some integration. We had to do some substitution. There was a fundamental theorem of calculus part 1. There was a total distance question. We don't want to be surprised if those things are on our test. Okay, here's a midpoint rule question. It says, use 3 subdivisions. So this is one of these where if you prepare, you would know what to do immediately. You would just not even have to think. You would just start writing. Notice I can do it as I'm talking. X0 is 2. X1 is 2 plus 2. This is always the width. That's how you can quickly do this, which is 4. X1 is 2 plus 2 widths, which is 6. I'm just adding 2 each time, but I'm emphasizing again that pattern. 3 times 2, which is 8, and I think I've gotten to the end. Good. So all we did so far is we split up the interval 4, 6, 8. Sorry, I bumped my mouse again. So here we go. And now the rest of the problem is going to be plugging in. You can even lay out the template. Now I have a little different, I tell students they don't have to get a decimal anymore. Okay, so you're just going to put delta x here because I'm trying to save you time. So all I care about is that you can put all the things in the right places. I'm not interested in testing your calculator skills here because I want you to have time to do other things on this test. So if you can put all the right numbers in all the right places, I will give you full credit, but you do need to put the right numbers in, meaning there needs to be a 2 here. If you factor it out, that's fine. That's also fine. And then it said midpoint rule. So we need the midpoint of this, the midpoint of this, the midpoint of this. So we need 3, 5, 7. You might have noticed I made a mistake. Let me correct my mistake. There's only 3 subdivisions. There we go. 3 subdivisions. We're off and done. That's it. You can stop right there. You don't have to do anything else. You just stop. So that's for an approximation question. I just want to see that you know where things go. Okay. You are standing on the edge of a building. So let me paraphrase this. Again, if you have trouble reading this is the winter 2015 exam that I'm working through here. You can pause and try the problem and then watch my discussion of it. So we're standing on the edge of a building. It's 100 feet above your instructor, so I'm down here. At what initial velocity would you have to accidentally throw a water balloon in order to hit the path in 2 seconds? So the question says we got a little something we're throwing down this way, and we want it to get here in 2 seconds. Okay, so all of these problems I do the same. We say, here's the acceleration. It's negative 32. So this is the setup if you're going to call the ground 0, h equals 0, and you're going to talk about the height. Just a moment here. Apologies for that brief interruption. Let me make sure the video is running again. Good. Okay, so here we go. So now we're going to do velocity is negative 32t plus c. Height is negative 16t squared plus ct. And these questions are all about your ability to work with the constants, not about your physics or anything else. So now we got to get the initial information. What do we know? We know that the initial height is 100. They told us that. We don't know the initial velocity. And it's not 0. It doesn't say dropped. You threw it downward. We actually know that this is going to be negative, but that's not helpful. So what do we know? We know what happens in 2 seconds. We know that in 2 seconds, the height is 0. So we have 2 facts. We just need to plug them in. That's it. That's what we're doing in these problems. So first let's plug in h of 0 equals 100. That implies that negative 16 0 squared. I know some of you can see right away this means d equals 100. That's fine. But I want you to get in the habit of always thinking about the fact that you're plugging in. Don't assume that your number is your constant. Okay, always plug in. So we're putting a 2 in this time. We're putting a 2 here. We now know this is 100, so I'm going to replace it with what it is. And we know this is equal to 0. So from this, we can solve for c. All right, I think this number here is 4 times 16. Is that negative 64 plus 2c plus 100 equals 0. So I get 2c is equal to, I think that's 36, negative 36. And so I get c is negative 18. Negative 18. And that's actually what we want, because that is the initial velocity. That's it. So you can get yourself a lot of points on this question just by saying, I understand what the problem is about. Okay, so let's look at that, make sure we're doing all right. Yeah, 18 feet per second downward. So hope you're getting the feel. We've hit a lot of the main points of exam 1. We did approximation. We did total distance. We had a fundamental geometric calculus part 1. We had quite a bit of integration. Can we do all those things? And then we get to this question, geometry question here. So it says you have this function, square root of x, y equals square root of x. You have this horizontal line, y equals 2. So y equals 2, and the y-axis. Apologies, let me do a little better at writing there. Y equals 2. And then it said the y-axis. That's why I redrew it, because here's the y-axis here. It says consider the region that's bounded by those. Okay. Got it, got it, got it, got it. Let's label a little bit. This is 0. Hold on, if y is 2, that must mean x is 4. All right, now we're ready to go. And then the question says, find the value of b so that you can draw a line here and it splits it in half. So you've done this type of question quite a few times. There's several ways to set it up. I mean, ultimately we need the total area. And you can do that in a couple different ways. If you want to do it with x, you're going to have to do top minus bottom. If you're watching this video before, we've talked about 6-1. This is going to be a little more confusing. But if you do it in terms of x to find the total area, the bottom is the square root of x. The top is 1. So this is going to be the total area. Another way to compute the total area would be to do the integral from 0 to 2, and then instead think in terms of y. And in terms of y, the left is 0, and the right is whatever this is, x equals y squared. So this would be right minus left. If you want to, you can try them both. This ends up being 1/3 y cubed from 0 to 2, which is 8/3. This should also be 8/3. Okay, so then the question is, you want to set something equal to half of that. So after doing this, I think it might be nice to work in terms of y. It looked like that was easier. So I think that we want the integral from 0 to b, if we're talking about this region, so 0 to b, of y squared dy to equal, so when is it equal to 1/2 of this? And then we're ready to go. So this is going to be 1/3 y cubed from 0 to b equals 6, not 6, 4/3. And so we're going to get 1/3 b cubed equals 4/3. B cubed is 4. B is 4 to the 1/3. Success. Okay, that's what those questions are like. So that's a little bit tougher setup question. Let's double check that I match my solutions. Yes, I do. Okay. And then we're going to do a volume question. So this is the new topic. I'll do, again, this is what we'll do in 6.2 and 6.3. Our exam will only involve the 6.2 method. So I will only ask about discs and washers. I will not ask about shells on the first exam in this course. But here's the thought process, just briefly. Again, this is, if we haven't done this in lecture yet, you can ignore this part. But it wants us to revolve around the x-axis. The washer method always cuts perpendicular to the axis of rotation. So this is perpendicular to the axis of rotation. And my advice is to always label whatever axis you cut across as your variable. And then my other bit of advice is there's a bunch you can do without thinking. The moment you know that it's x, you write dx. You also can do what the bounds are, which is going to be 0 to 4. which is the biggest and smallest x can be. And then you start to do this thing. Now, in this case, what we're trying to do is we're saying if you're at a particular value of x and you draw a little rectangle, and then you rotate that around, that gives rise to something we call a washer. And the entire idea, which we'll talk about in 6.2, is can we find a pattern for the area of that washer? And basically what we're going to do is area times thickness, and then we're going to add those up. And if you do that, you're adding up these thin volumes, which add up to the total volume. It's a similar idea to what we've done. So now the question is, well, what is the area of a washer? The area of a washer is the area of the big circle minus the area of the small circle. So we're going to do the area of a big circle minus the area of a small circle. But the question is, what's the radius? So the whole point of this question now is, how far is it from here to here in terms of x? And how far is it from here to here in terms of x? Now the upper one, hopefully you can see the bigger radius is just 2. So the bigger radius is always 2 no matter where you are. The smaller radius changes, but it's given by the square root of x. That's it. You don't even have to simplify. I just want to see the things go. On these problems, I will say do not evaluate. All right, so I think we made it all the way through. There's an exam. I hope that's helpful. You can just go to the exam archive and work through a lot of these, but you really have to, you can't just look at my solutions. You have to actually do it. Do it and could I do this? Would I know how to start it? Would I be able to write a lot of stuff? Could I do this page in 10 minutes? Could I do this page in 10 minutes? You need to practice a lot. The test will be challenging. This will decide your grade more than other things. You need to practice. Hope that